So we are going to continue our detour into how we mathematically represent these operators formulas. अब हम कल yesterday we just arrived at this thing. We can write psi and A of psi, so we can write it in terms of this. So if we can take two matrices in the property, we just prove it. And at the end, we can write this inner product of this in terms of these matrices with two indices. Now the subsequent part of this lecture is if you see example 9.4 if you see example 9.9. So example 9.9 says exercise. Prove that the multiplication rule. The rule was like this. You should arrive at the end. This multiplication rule, where we wrote this in product in terms of two indices, which can be supposedly represented by two matrices. So and directly from, so we have to prove this multiplication directly from this 9.55. Physics student. E psi j is sigma I is equal to 1 to n psi I E I j. So we can, so we have to directly show that we have to do this. This inner product can be written as in terms of product of two matrices, each having two indices. You can directly see it from this operator. This operator acting on psi can be written as psi in the prefix having this thing. So what we are going to say before trying to see it in this way, we are going to make a comment. Comment ये है कि the comment is that here, since we have proved this identity for matrices, these indices, so but we are normally interested in operators, how operators act on states, and what do they are given by some identities. But the thing is, जो हमारा operators को in terms of matrices लिखना identification, so it cannot be always like that because the identification means, because जो matrix है it depends upon choice of basis vectors. और जो हमारा what I should say operator A है, so it has basically geometrical intuition. When you talk of orthonormal, orthogonal, so it will vary for or geometrical intuition or geometrical entity, which will be represented by different matrix in every representation. So matrix A depends upon the choices of basis vectors. ये है, तो ये कहने का मतलब ये है कि जो हमारी आइडेंटिफिकेशन है मोड मैट्रिक्स विद ऑपरेटर, इट्स नॉट एंटायरली perfect, because matrix sometimes can depend upon the choice of basis vectors. So basis vectors may depend from choice to choice, while as operator, so for every representation it might have a different thing operator. So the question is how can relate one basis set with another basis set. That's also an exercise which we will do, but फिलहाल हम ये कहेंगे कि that इनका आइडेंटिफिकेशन जो है इट्स नॉट एंटायरली आइडेंटिकल. सो so if a dagger is called Hermitian adjoint, of A which has the property of two psi vectors. So we can have psi of A dagger psi of B can be written as. So if you flip this to this prefix को यहाँ लाएंगे, second indices, second term का जो ये है inner product का, we will take it here, so it will become psi B. So the property of inner product में ये होगा कि once you change this dagger it will become this symbol. So for unit vectors, psi E is equal to psi I and psi B is equal to psi J. So for unit vectors, psi E is equal to psi I and psi B is equal to psi is equal to So we have been doing so हमारा जो previous ये था कि for matrix वो है this property that the inner product of two states जो है psi and A psi की है ना can be represented as in terms of two indices. ठीक है. अब हमारा क्वेश्चन ये है कि जो हमारा operator acting on this psi, so you can also represent it as this. अब the exercise in the book is can we prove that this. So we have to prove it from this ये a property true for matrices. For matrices में है ना aij plus bij है ना, it will be equivalent to a plus b ij है ना. तो ये एक प्रॉपर्टी है अगर इंडिविजुअल इंडिसेस मैट्रिक्स को दे विल ऐड अप. अब ये है कैन वी डू द सेम थिंग फॉर स्टेट वेक्टर psi, उनका जो इनर प्रोडक्ट होता है. ठीक है. सो इन द स्टेट वेक्टर psi इफ यू ऑपरेट एक्ट्स ऑन psi वी कैन आल्सो रिप्रेजेंट लाइक दिस. यह है ना दो इंडिसेस I will sometimes get absorbed, so you can also write it as psi of j है ना. इस तरह आप मैट्रिक्स करते हो जैसे 2 क्रॉस 1 मैट्रिक्स हो, इसको मल्टीप्लाई करोगे 1 क्रॉस 3 1 क्रॉस 2 तो ये आएगा 2 क्रॉस 2 मैट्रिक्स है ना. m क्रॉस n है ना, m क्रॉस n को मल्टीप्लाई करोगे n क्रॉस l, ये क्या आएगा मैट्रिक्स m क्रॉस है ना. सो इन द सेम वे so you can write operator acting on this psi state psi, you can write it as psi of this aij. तो यहाँ दो इंडिसेस. अब ये कह रहा है कि we prove this property directly, we have not to take recourse to matrix. We directly prove this thing from this. ठीक है. तो हम before we are going to say something, so we are going to make one comment कि जो हमारी total identification है with matrix algebra and operator algebra, it's not 100%, क्योंकि matrix algebra जो है तो it may depends upon the choices of the basis vectors. तो बेसिस वेक्टर्स जो इन्फिनिट डायमेंशनल जो वेक्टर स्पेस जो है उसकी बेसिस वेक्टर्स है जो बिल्डिंग ब्लॉक्स है उसका क्या है बेसिस वेक्टर किसी सब्सिडी मैट्रिक्स में फॉर्म करेंगे, ठीक है। बट जो हमारा जो ऑपरेटर ये है इट हैज ए ज्योमेट्रिकल इंट्यूशन मीन्स जिसको हम कहते हैं ऑर्थोगोनल कंपोनेंट्स विल नॉट कंट्रीब्यूट, ऑर्थोनॉर्मलिटी कंडीशन आएगी तो इट विल वेरी फॉर इट मे बी डिफरेंट मैट्रिक्स फॉर एवरी रिप्रेजेंटेशन, ठीक है। Although we can represent this with this, but we have to make some qualification. It's not always the case. अब है कि there is an exercise by which we go from one basis vector to another basis vectors, which we will do later. फिलहाल हम ये रखते हैं। तो अब ये है कि अगर ये इनर प्रोडक्ट इनका ये है, for example, psi of A. So the properties इसका prefix यहाँ लाएंगे for Hermitian. So A dagger will become A, it will be psi of A, psi of B. Or so if psi of A, psi of B, these are unit vectors. These are unit vectors. इनका आप so you can say A dagger I of J is equal to A star J of I. A dagger I of J when you have इसका Hermitian का ऊपर conjugate I J will change into J I, and that's it. और for this thing A dagger जो property होती है complex conjugation की, it's a matrix of transpose of that complex conjugate. है ना तो that's the we are basically dealing with Hermitian properties, Hermitian conjugate, Hermitian operators which are very much used in quantum mechanics. So उनकी properties we are going to enumerate उनका inner product. So if you want to see it in some general sense, psi of A psi of B will be equal to Schauer's. अगर इसको यहाँ लाएंगे तो क्या आएगा Schauer's A psi of B psi of, so it will be, so if you flip इसको prefix को यहाँ लाएंगे so it will become complex conjugate, ठीक है। again इसको again यहाँ लाओ आप, again it will be psi of B A Schauer's, it will be A dagger psi of B. So again if you want to इसको यहाँ लाओगे A dagger psi of A और पूरे को लाएगा psi of A psi of. So these are different ways जो inner product है ना, inner product को हम inner product this is linearity property, ठीक है। So inner product को हम ऐसे लिख सकते हैं, ऐसे भी लिख सकते हैं, but in everything we see we change prefactor, यहाँ पर you just see here we change prefactor, just see here prefactor को हमने यहाँ लाया, ठीक है। once you change it so it will become complex conjugate. So if you again do complex conjugate it will become dagger. Okay, it's a better matter of time. So so we can say so position as a multiplier of a post vector, ठीक है। So the important theorem containing this thing is that AB dagger is going to B dagger A dagger. एक तो हमारे पास एक लीनियरिटी प्रॉपर्टी हमारे पास है क्वांटम ऑपरेटर्स की, एक प्रॉपर्टी है एंटी लीनियरिटी प्रॉपर्टी। तो अगर लीनियरिटी प्रॉपर्टी एक्सरसाइज 9.10 कह रहा है कि इफ A is a linear operator show that it is generally not possible to define a transpose linear operator A which satisfies this thing. Psi of A is equal to psi of A psi B. If A is a linear operator, show that it is generally not possible to define transpose of linear operator which satisfies this thing. Linear operator में property होती है for Hermitian operator A dagger is equal to E. इसी तरह कल हमने, चलो दिस इज एन एक्सरसाइज, you can show that the exercise is if A is a linear operator, show that it is generally not possible to define transpose of linear operator which satisfies this condition. ये है, so this is an exercise, चलो आप you try attempt at it please, if it's a linear operator. And further कल हमने what we did also is something called projection operators. Projection operators दूसरा हमारे पास आइडेंटिपोटेंट मैट्रिक्स है ना, ए स्क्वायर इज इक्वल टू ए, है ना, जैसे कोई मैट्रिक्स है ना, जैसे 1 0 0 1, इसका आप स्क्वायर करो, मल्टीप्लाइड बाय 1 0 0 1, इट विल अगेन कम आउट टू बी, so this idempotent property is similar to like that for projection operator, and projection operator operates on a given state psi and he comes back, ठीक है, उसकी अपनी प्रॉपर्टीज होती है, एंड दो प्रॉपर्टीज आर हेल्पफुल, यू प्रोजेक्ट a state, operate on something, and square of the projection gets the state back. अब ये है कि फॉर हर्मिटियन ऑपरेटर्स, for Hermitian operators, for example, an Hermitian operator, it's very discussed. For Hermitian operator, psi of A psi of E is equal to A psi of A psi of A is equal to psi of A psi A star is real. अब ये है कि इसने यूज किया है हमारा प्रोजेक्शन ऑपरेटर PA, प्रोजेक्शन ऑपरेटर PA, such that we can write, so if you don't know what's a projection operator, you can go and check back the book यहाँ पर, see how we define projection operator, like this: P of A acting on psi of A is psi of A, या P square A psi is P of A psi, so this is psi of A psi is psi of A psi is P of A. जनरल प्रोजेक्शन ऑपरेटर्स की प्रॉपर्टी होती है इसको टू, so for projection operator, this thing, psi of A, projection of operator on psi of C can also be written as from this, if they are unit vectors, we can also write it like here, we can write them as psi of A, psi of B, psi of A, psi of A of C, इसका ये, or you can write them as psi of A, psi of C, psi of A, psi of C, psi of A, psi of C, psi of B, psi of E, psi of B, psi of E. So these are different ways of writing it. और अगर आप इसका complex conjugation लेंगे, psi of A, psi of B, psi of A, psi of B, इसको आप यहाँ लाएंगे, so you can also write it as psi of A, psi of C. So you can see, if you inner product में अगर एक जगह आप flip करोगे, यहाँ लाओगे, it will become complex conjugate, ठीक है? और psi of A, psi of B, psi of C, psi of C. Or you can write it as projection operator of psi of B, psi of C. इसी तरह एक और प्रॉपर्टी है हर्मिटियन ऑपरेटर की, psi ऑफ ए psi जो है इसका वैल्यू अगर ऑलवेज ग्रेटर देन 0 होगा, इसी को हम कहते हैं, इसको कहते हैं पॉजिटिव डिफिनिट. ठीक है, पॉजिटिव सेमी डिफिनिट रादर इज मोर एक्यूरेट टर्म. ठीक है, बिकॉज ये इनर प्रोडक्ट है ना इसका, ए को आप बाहर भी ला सकते हो. ए साइड स्क्वायर इज इक्वल टू 1. ठीक है, और ग्रेटर देन 1, सो इट्स ऑलवेज इसका कोई वैल्यू होगा. ठीक है, इनर प्रोडक्ट ऑफ साइड ए इज सम स्केलर ऑपरेटिंग अपॉन ए इज सम थिंग ऑपरेटिंग ऑन साइड. ठीक है, अब अगेन ये कह रहा है कि प्रूव दैट पॉजिटिव, प्रूव दैट प्रोजेक्शन ऑपरेटर्स और पॉजिटिव डिफिनिट. तो पहले तो we'll go to our definition of projection operators. How we define projection operators? Projection operator operating on psi A gives psi A back, or projection operator P square operating P को फिर एक बार P at the end it will get P A set back. अब ये कह रहा है कि इसको ये प्रोजेक्शन ऑपरेटर की एक प्रॉपर्टी है दैट दे आर पॉजिटिव डिफिनिट. इनमें एक थ्योरम आपने सुनी, कॉची-श्वार्ट्ज इनइक्वालिटी. हैव यू हर्ड ऑफ इट? तो कॉची-श्वार्ट्ज इनइक्वालिटी यूज होती है. वी रादर से इट, हम विल रीडिफाइन psi in terms of psi A plus lambda psi of B. Here psi A and psi B are arbitrary vectors, and lambda is a complex number. तो psi of A, psi को हम कैसे लिखेंगे? अब ये psi है ना, psi is basically what? Psi is psi A plus lambda psi B. So हम इसके psi के एक तो नॉर्मल लिखे, psi is lambda psi, फिर psi के कंजुगेट भी. So we get 4 terms here. और फिर lambda एक आएगा lambda, दूसरा आएगा lambda कंजुगेट. ठीक है, so it will जो फॉर्म इसकी आएगी ऐसे, psi A psi A प्लस सेकेंड टर्म इसकी psi A psi B. ये तो आगे ये रियल. नाउ we'll take complex conjugate वाली terms. So we'll take lambda square psi B A psi B plus lambda star psi B A psi B is greater than 0. अब ये क्वेश्चन है कि हाउ, सो इट विल कम स्केलर, ये कॉम्प्लेक्स कंजुगेशन, ये लीनियर कॉम्बिनेशन ऑफ कॉम्प्लेक्स कंजुगेट एज वेल एज दिस lambda and lambda. So we can write if we redefine psi in terms of this psi A and lambda psi B, तो इसके 4 terms आ सकते हैं. ठीक है, either it will be this, or we can have a scalar outside, or we can have a complex conjugation of a scalar, or we can have a complex conjugation as well as scalar in charge formula. So if we differentiate it and the value of lambda accomplished can be found to be, अगर इसको differentiate करोगे तो 2 terms 0 आएंगी, तो it will come out to be lambda minus psi B, psi B A psi B, psi A psi A psi B, psi B A psi B. एक ये आएगी और दूसरी आएगी psi of A psi B conjugate psi B A psi of B. अभी इसमें यह है कि इफ यू चूज ए इज इक्वल टू 1, इसी को हम शोज इनइक्वालिटी भी कहते हैं, ठीक है। इफ इसको आप यहाँ लाओ, यहाँ पर साई ऑफ ए साई ए इंटू साई ऑफ बी, ए साई ऑफ बी is greater than or equivalent to modulus of psi of A psi of B का whole square. If A is 1, इसको कहते हैं Schwarz inequality. Psi of A, psi of A, psi of B, psi of B, है ना? Inner product इसका psi of A, psi of A, ये A है. इस A is equal to 1 जो स्केलर है, so it is greater than or equivalent to psi of A psi of B square. Maybe you just have an exercise a bit. How we can arrive at it? We arrive at it by differentiating, and that's it. Basically, इसका ये important thing है, just like आप करते हैं ना dot product earlier classes, modulus of A, modulus of B into cos थीटा, है ना, A डॉट, तो cos थीटा किसके बराबर है, A, है ना। अब इसी तरह ये हमारे पास अगर दो स्टेट वेक्टर्स हैं, साई एंड साई ए, साई बी, बट इनकी कोई प्रोजेक्शन हो सकती है, दे कैन बी ऑर्थोगोनल और दे कैन बी ऑर्थोनॉर्मल, ठीक है। वो स्टेट्स को हम कैसे रिकंस्ट्रक्ट कर सकते हैं, ठीक है, बेसिस बाय बेसिस, पॉइंट टू पॉइंट, ठीक है। सो इन दैट सेंस अगर हम ये इसका एनालॉजी लेंगे विज़ावी दैट डॉट प्रोडक्ट, इट विल बी लाइक दिस, इट विल बी लाइक, it will be cos of alpha is psi of A, psi of B, root of psi of A, psi of A, psi of B, psi of B. ये है ना बेसिकली इसका ये आएगा, ये बेसिकली है ना, ये cos of theta is basically modulus of A, modulus A of B, ये modulus of A है ना, modulus of B है ना, square. Yes, you can write it as ये square of this thing. So you can write it as psi A psi. ये psi square आएगा, ये cancel हो जाएगा, psi A psi, ठीक है। So these are two states. So you can write it. What's that? That's it. So further इसका inner product आएगा psi square. It will cancel with this. Inner product आएगा psi B square. It will cancel this. You can write it like psi A, psi B, modes of psi A, modes of psi B. अब इसमें ये है कि if psi is equal to 0, cos 0, yes, we have redefined psi in terms of psi of lambda, psi of B, so we can have this thing. In the same way हमारे पास जो लीनियर ऑपरेटर है, अगर हमारे पास दो स्टेट है, psi prime is equal to A psi and psi is equal to B psi prime, and psi and psi prime or psi and psi B, psi so psi and psi B are two different, for example, psi A prime and psi B prime are two different vectors of psi and psi B of A which preserve linear independence. Linear independence में क्या होता है? Alpha 1 A1 plus alpha 2 A2 plus so on is equal to 0. Here alpha 1 is equal to alpha 2 is equal to linear dependence में वो चीज, if linear independence है दो, we may substitute 9.45 from, we can substitute this it here. Means for a particular, you can have two states which will correspond to the same value. So which means that AB is equal to I and BA is also equal to I. Means they can be two commutative operators. ठीक है, क्योंकि स्केलर की वैल्यू सेम आएंगे ना for the linear independence. ठीक है, you can say it that. So you can have if AB is equal to I, BA is equal to I, that means and further हम इसमें ये कर सकते हैं, इसमें हम कर सकते हैं काम. You can also define AB prime is equal to I or BA prime is equal to I. From this you can have two identities. A of B minus B prime is equal to 0 or B of A B prime minus B is equal to 0, है ना. इसको इसमें subtract करो आप, A को बाहर निकालो, B minus B prime, I minus I is equal to, और यहाँ से ये आएगा. And from this you can say that if B is equal to A inverse, तो हमने क्या कहा था, हमने यूनिटरी ऑपरेटर्स में क्या कहा था, A is equal to A diagonal is equal to A inverse. This is the definition of unitary operators. Either it's equal to its Hermitian component or it's equal to, provided उनका जो modulus of A is not equal to 0 in the condition. From that property. So from this, if B is equal to A inverse, you can, and B को आप A1, A2 से define करेंगे, you can say from this A1, A2, another property can be arrived at A2 inverse, A1 inverse. ठीक है, from this. So these are, we are basically seeing these different properties of unitary matrices, Hermitian operators, projection operators. ठीक है, these things, because that will be they will be helpful. जैसे इसमें exercise 9.12 ये कह रहा है, show that the projection operator has no inverse in the vector spaces has more than one dimension. So further one thing is that so a linear operator whose inverse and adjoint are identical is called unitary. So unitary operators है ना, unitary matrix, so they are very much throughout quantum mechanics में यूज होते हैं, जो अभी मैंने कहा. A linear operator whose inverse and adjoint are identical is unitary. Means U inverse is equal to U diagonal, और U diagonal U, अगर इसका U inverse है ना 1 by U, ये यहाँ से जाएगा, U diagonal is equal to 1. Or you can also write it, you can change this, U diagonal is equal to 1. ठीक है. So this is an important operator. तो इसी का अगर inner product लिखेंगे, inner product how can we write it? Inner product psi of A, psi of B, mu psi of A, mu psi of B. Okay. So you just leave it. And last exercise which we are going to see is, for example, exercise 9.13. You see, ये कह रहा है कि prove that the products of unitary operators are also unitary. तो कैसे करेंगे? तो unitary operators की एक प्रॉपर्टी होती है A इनका जो कम्यूटेटर होता है ना वो 0 होता है. ठीक है. So what we are going to do? We are going to write A in terms of its Hermitian conjugate. You can write A as A plus A diagonal by 2 plus iota A minus A diagonal by 2 iota. लिख सकते हैं, है ना. iota cancel, 2 common, A plus A diagonal A minus A diagonal minus A diagonal cancel हो जाएगा, ये 2 A आएगा, 2 कट जाएगा, A is equal to A. So you can write A in terms of A plus A diagram, iota A minus A. अगर हम ऐसे लिखेंगे तो you can A को इसमें लिखेंगे Hermitian H and the other is Hermitian conjugate, where H1 and H2 are Hermitian operators, and they can be seen only to be normal if their commutator H1 H2 is D. So commutator किसको कहते हैं? A dagger, once A dagger A is equal to D. तो हमने देखा था ना, in case of some operators it may not necessarily come out to be, because you जब हम operate कर रहे हैं ना, when you change operate, if you change it sometimes it may not be the same. ठीक है, if you इसको यहाँ रखेंगे, इसको यहाँ रखेंगे, because it's operating on something, ठीक है, but so it will not always be the same. But here for two, if you write in this thing for Hermitian operator, this commutator comes out to be 0, which you can see it from here. अगर H1 को आप ऐसे लिखेंगे, आप just do the exercise आप अपनी जगह, ठीक है, try to do it here. जैसे A plus A dagger by 2 iota A minus A dagger by 2 iota. पहले करेंगे काम A plus A dagger by 2 into iota A minus A dagger by 2 iota minus, अब रिवर्स iota A minus A dagger by 2 iota into A plus A dagger by 2. ठीक है, अब टर्म बाय टर्म देखो, इसको इसके साथ यहाँ 4 टर्म आएंगे, यहाँ 4 टर्म, दिस विल कैंसिल, दैट विल कम आउट टू बी 0. ठीक है, तो वही है कि जो हमारा पास ये है हर्मिशियन ऑपरेटर्स का कम्यूटेटर है, इनकी प्रॉपर्टी है, इट विल कम आउट टू बी 0. ठीक है, so these were some of the properties of these things: projection operators, unitary operators, Hermitian operators, उनका inner product, and how they are related with matrix properties also, and how the operators may sometimes their definitions may coincide. अब ये है कि how can go from one basis to another basis, that we will do in coming class. So we stop. ठीक है.